In this video, we're going to talk about degrees and radians. First, when we talk about an angle, when you measure an angle, you have two rays that determine an angle: initial side and terminal side. These are two rays that determine the measure of an angle. And the point where these two rays meet is called the vertex. Now there's angle in standard position. When you have x and y axes, the initial side always lie on the positive x-axis. Now this is when angle is in standard position. Now the terminal side could lie anywhere. First, second, third, fourth quadrant, or it could lie even on the y-axis or negative x-axis. It doesn't matter where the terminal side is, but initial side has to be on the positive x-axis when the angle is in standard position. Now, when you measure an angle in a standard position, if you measure an angle counterclockwise, then the angle will be a positive angle. But when you measure the angle from initial to terminal, you go clockwise, then the measure of an angle will be negative. So for example, let's say you have initial and this is terminal, that will be positive 45 degrees. But when you measure an angle, this is the initial and this is terminal. When you go clockwise, we could call this negative 45 degrees. Now we're going to talk about radian measure. You guys are used to degree measure, but why do we need radian measure? Well, when you measure a distance, it doesn't make sense that something is 5 feet degree. So when we measure a distance, we need to change degree to a radian. And in order to do so, we need to talk about the concept of the measure of theta respect to the measure of intercepted arc, which is represented by S, and the radius R. It turns out that theta it's a ratio of the length of the intercepted arc S to the radius R. So theta equals S over R, where theta is measured in radians. So since theta is equal to S over R, and when you have a circle, and when you go one revolution, that is same thing as 360 degrees. Now, what is the measure of this intercepted arc? That is going to be the circumference of a circle, which is 2 pi r. So it's going to be 2 pi r divided by r. So r cancels out. You get 360 degrees equal to 2 pi. And divide both sides by 2, you get pi is equal to 180 degrees. So basically 180 degrees is pi radian. So if you want to convert degree measured to radians, you need to multiply by pi over 180 degrees. And if you want to convert radian measure to degrees, you need to multiply by 180 degrees over pi. And let's take a look at some examples. Let's change 120 degrees to a radian. You know that when you want to change degree to a radian, you got to multiply by pi over 180 degrees. Because pi is the same thing as 180 degrees. So basically, you're multiplying this by 1. It's just that now you want to change a degree to a radian. So then you get 12 pi over 18. And you can still reduce. That becomes 2 pi over 3. So 120 degree is same thing as 2 pi over 3 radian. Now if it's a radian, you don't need to write radian. This is good enough. What about negative 45 degree? Again, this is a degree, so if you want to change it to radian, you multiply by pi over 180 degree, and you get negative 45 pi over 180, which is the same thing as negative 5 pi over 20, and you could reduce further, negative pi over 4. So negative pi over 4 in radian is same thing as negative 45 degree. Now let's turn the radian to a degree. You have 5 pi over 6. So when you want to change radian to a degree, now you got to do multiply by 180 over pi. So pi cancels out, and 6 goes into 180, 30. 30 times 5 is 150 degree. So 5 pi over 6 is same thing as 150 degree. What about negative 3 pi over 2? Again, we're going to multiply by 180 degree over pi. Pi cancels out. 2 goes into 180, 90. 90 times 3 is negative 270 degree. By the way, if you have a pi and if you want to change it to a degree, you could just plug in 180 right away and you'll get the answer.